Hello everyone, this lecture is exclusively recorded for third year BSc student of BK Birla College, Kalyan. This is mathematics class, paper 1. So in this lecture, we will solve some example of surface integral. We will see how to find out the surface integral of a given function. So the question is as follows. So if f of x comma y comma z is equal to x square, find the surface integral f ds where s is surface of the plane, x plus 2y plus 3z is equal to 6 in first octant. Well, the solution is as follows. So we need to find out a parameterization, and then there is a standard definition to find out the surface integral. First of all, let us draw this tetrahedron. So we can easily identify the 3 points from the tetrahedron: 6, 0, 0. Then this is x-axis, this is y-axis, this is z-axis. Then 0, 3, 0 and 0, 0, 2. So this tetrahedron, when we say in a first octant, that means x is equal to 0, y is equal to 0, z is x is greater than 0, y is greater than 0, z is greater than 0. Okay, so this surface integral we have to find out. So let alpha from t subset of R2 to R3 be a parameterization. So this R3 basically we are parameterizing this and for the surface S. Okay, be a parameterization for surface S. So let me define what is alpha x comma y. So it is x comma y comma 6 minus x minus 2y upon 3. Okay, so what is t here? You can see that t is basically the projection of this. If I take in the projection, then z is equal to 0. That will give you x plus 2y is equal to 6. So this means it is 6 comma 0. This is 0 comma 3. Projection on the xy plane. This is x plus 2y less than equal to 6. So when and x is equal to 0, y is equal to 0. So basically this is what my project. That's a standard triangle. You can observe. Okay, so let me take the we know how to find out the surface integral. Sorry. So we know that surface integral of f dot ds over s is equal to, since it is a scalar field, because f of x comma y comma z is equal to x square, so it is double integral over t f of alpha of x comma y into norm of dou alpha by dou x cos dou alpha by dou y, norm complete, dx dy. Okay, so let's find out dou alpha by dou x. So dou alpha by dou x is 1 comma 0 comma, it is minus 1 by 3. Dou alpha by dou y is 0 comma 1 comma minus 2 by 3, and then I need to find out the cross product, dou alpha by dou x cross dou alpha by dou y. This, if you find out this cross product, then this will be 1 by 3 comma 2 by 3 comma 1, and the norm of this dou alpha by dou x cross dou alpha by dou y, this norm will be root 14 by 3. This you can calculate. Okay, now then here, so I need to, this value I have calculated, this value is, so let me call this as an star expression. So norm alpha x by x cross alpha dou alpha by dou y, this norm we have calculated. What is f of alpha x comma y? Let's find out this. So f of alpha x comma y is equal to f of alpha x comma y is basically x y 6 minus x minus 2y upon 3, because alpha x comma y is, if I'm not, yeah, x6 minus x minus 2y by 3, correct. But what is f of x comma y comma z? So this is x only, this is y, this is y, this is z. So it is x square. So it is x square, that means first component square, so x square only. So therefore from star we will get the surface integral s f dot ds is equal to double integral over t. So f of alpha x comma y, that is x square only, and that norm is root 14 upon 3 dx dy. Now we have a standard triangle, so we can easily find out the double integral of this t. So let's go with the type 1. So x will be from 0 to 6 and y will start from 0 and will end on this line. The equation of this line is 6 minus x upon 2. So let me write down this. It is same as 0 to 6, 0 to 6 minus x minus divided by 2 x square root 14 upon 3 dx dy. So I'm not interested, sorry, the order of integration will be d by dx, not dx. So I'm not interested to solve this. I'm sure that you all will solve this, and I will just put the final answer. After solving this, you should get answer as 18 root 14. So this completes the problem number 1. Let me go to the another problem. Question number 2. Yeah. So it is given that when the function is given as follows. Yeah. So the question is, find the surface area of S, where S is the portion cut from the paraboloid z is equal to 1 minus x square minus y square by the plane z is equal to minus 3. Okay, so let's imagine the surface first. So z is equal to 1 minus x square minus y square. This is a parabola whose vertex is at 0, 0, 1, and it is downward parabola. This is infinitely long, right? But it is said that z is equal to minus 3. It will cut from z is equal to minus 3. So this is z is equal to minus 3. So z is equal to minus 3. So the surface which we have is as follows, that this inverted cup, like चाय का कप को अगर आप उल्टा किया तो it will of this side. So that surface integral we have to find out. Well, you can have, there are various ways to solve this. So the alpha x comma y, I can take it as x, y, and z is straight away given as 1 minus x square minus y square. Then you can find out dou alpha by dou x, dou alpha by dou y, and then, so let me calculate here, dou alpha by dou x, it is 1, 0, minus 2x, dou alpha by dou y is 0, 1, minus 2y. Then we need to find out the cross product, dou alpha by dou x cos dou alpha by dou y, that is 2x comma minus 1 minus 2y, and then the norm of this, that will be under root of 4x square plus 4y square plus 1. So what will be the image projection of this if I collapse this on xy plane? So when z is equal to 0, uh, uh, what will be the image of this? That's important, because yeah, so because if you take this z is equal to minus 3 here, then it will be x square plus y square is equal to 4, and that will be the projection. So here the projection t will be a disk x square plus y square less than equal to 4. Okay, so then we need to find out this surface integral. So surface area of S is equal to double integral over t. So this is t, 1 times, it is dou alpha by dou x cos dou alpha by dou y dx dy. That doesn't matter, order doesn't matter here. So it is double integral over t under root of 4x square plus 4y square plus 1 dx dy. Okay, so you can use the polar transformation. So by polar transformation, your x is arc cos theta, y is arc sin theta, r is 0 to 2, and theta is 0 to 2 pi. So it is 0 to 2 pi. Here you will have 4r square plus 1, and r is 0 to 2, and here it is Jacobian is r dr d theta. Okay, so d theta integration will be straight away 2 pi, it is independent. So you just need to find out this integration. So we can use a change of variable formula. So we can say put 4r square plus 1 is equal to some t. So 8r dr is equal to dt. So r dr is equal to dt upon 8. So this integration will be when r is equal to 0, t is equal to 1. When r is equal to 2, substitute here. When r is equal to 2, then this is 4, 4 into 4, 16, 16 plus 1, 17. So it will be 70 in that time. 70. So this is under root of t. R dr will be dt upon 8. So it is 2 pi by 8. So t raised to 3 by 2 upon 3 by 2, 1 to 70. So this becomes 4. So pi by 2. So 6. It is 17 root 17 minus 1. So this will be the answer. Of course, you can cross check this with your calculation. Okay, so the next question is as follows. Question number 3. Find surface integral of f. That surface integral of s f ds, where f of x comma y comma z is equal to xyz, and s is the surface of the cone z square is equal to x square plus y square between z is equal to 1 and z is equal to 2. So let's solve this. So this cone, since we are having the region between z is equal to 1 to 2, so we will not have downward cone, or we will only have the upward cone, because I need to have the 2 z is equal to 1. So this is z is equal to 1. This plane is z is equal to 1, and here I have a plane z is equal to 2. So my surface is between this surface I am interested. Right. So writing parameterization is very important. So here alpha, it is a part of cone. So it is x comma y, alpha x comma y is x comma y comma under root of x square plus y square. This is one way. Or we can use the cylindrical transformation. So x is r cos theta, y is r sin theta, and z is basically uh, it is under root of x square plus y square. So z square is equal to basically r square. So z is equal to r. So this way we can take the parameterization. And then it is r and it is theta. So then you can find out dou alpha by dou r. Then similarly you find out dou alpha by dou theta. Then you find out dou alpha by dou r cos dou alpha by dou theta. This is to be calculated, and after that once you have this all, then you need to take the norm of this, because surface area is this basically norm of dou alpha by dou r cos dou alpha by dou theta. So then surface integral is basically f dot ds is basically double integral over t f of alpha of x comma y. Now here it is r comma theta into dou r alpha by dou r cos dou alpha by dou theta into dr d theta. This is by definition of surface integral. By definition of surface integral of scalar field. Now what is f of alpha r comma theta? That also I can calculate. So f of or maybe let us calculate this here itself. So okay. So f of alpha of r comma theta is basically f of alpha r comma theta is r cos theta, r sin theta, and it is z is r. So this is basically my x, this is my y, this is my z. So f of x, y, z is x into y into z. So it will be r cube cos theta sin theta. Right? So this you have to find out. And now here you can substitute this f of alpha. This can be replaced with r cube cos theta sin theta. And this also you need to find out. So you need to know what is projection. So if I want to take a projection of this, then what will be the projection? So the projection is here, it will be two concentric circle. So like projection, so it will be the first circle will be of radius 1 and the second circle will be of radius 2. So I will have a two circle whose first radius is 1 and second radius is 2. So this one should understand, imagine. So if you could not imagine, not to worry, in a lecture you can definitely ask this question. So we will discuss in more details. So here my theta will be 0 to 2 pi, but the radius will be 1 to 2 only. Because if I substitute x is equal to 1 here, then I will get x square plus y square is equal to 1. And z is equal to 2, I will get 4 is equal to x square plus y square. So radius is 1 to 2. So here, so even t has the following range. On t, you will find out it is set of all r comma theta such that r is between 1 to 2 and theta is between 0 to 2 pi. Then your next task is to find out the surface integral. So surface integral over s f dot ds is theta is 0 to 2 pi, r is 1 to 2, then f of that will r cube cos theta sin theta, and then that norm also you need to find out. Yeah, here it should be norm. I did a mistake. So I hope you will calculate the norm. So I'm just writing now it is norm of dou alpha by dou r cross dou alpha by dou theta. I have not calculated, so dr d theta. And this answer will ultimately lead to 0. So that you can solve. Okay. So now there is a last question. That will be question number. So far we have done the 3 questions. So question number 4. Evaluate surface integral of f of x comma y comma z is equal to y square over the surface S, where S is cylinder, x square plus y square is equal to 1, z is between 0 to 1, and its top and bottom. So here the cylinder is not hollow now. When I say z is between 1 and 2, 0 and 1, that means the my surface area. So far we were only calculating the, if it is cylinder, so cylinder was given, and we were only interested to find out the outer part. But now here it is said that the top and base and top is also should be considered. So this base and this, the surface, the complete surface is basically yellow and green. But you can see that on a green line my x is 0, sorry, x is x, y is y, and z is equal to 0, such that x square plus y square is equal to 1. Similarly, on this top, you can observe that it is uh, x is x, y is y, but z is equal to 1. So I will divide this into three surfaces. So this is surface S1, this is surface S2, and this is surface S3. So I will give a parameterization for each surface, and then we will club all the parameterization. So solution. So for surface S1. So what will be the parameterization for surface S1? So it's a cylinder basically, where the cylinder Z goes from 0 to 1. So whenever there is a cylinder, we can always use a cylindrical transformation. So x is equal to r cos theta, but radius is constant. So cos theta, y is equal to x is equal to r cos theta, y is equal to r sin theta. So sin theta, r is 1, and z is z. So it is theta comma z. And here you can observe that theta is between 0 to 2 pi, and z is equal to 1. uh, uh, Z is equal to 0 to 1. So I'm not, see, if I give the parameterization, then you can explore the entire this problem solving with this norm and all. So I'm assuming I will not do this now. I will be writing this surface integral over S1 of f dot ds, that will turn out to be pi. You can always cross check maybe, but most of the times my answers matches, but I can always suggest that please you should call cross check. So for surface S2, so you can observe that for the surface S2, so y your z is 0, so how will be the parameterization f of x comma y? It's in fact, it will be very simple, because it's a only circle, it is only a disk. And what is the parameterization for this? It is r cos theta, r sin theta, and z is 0. Now here you can see that r, because when I say surface, this radius will be changing. So the point here, this all are the included in the surface. And if you calculate this with this parameterization, of course my r is between 0 to 1 and theta between 0 to 2 pi. So I will just suggest, if you solve this, then you will get the integral of S2 f dot ds as pi by 4. So you can check out that. Now I just want to say this, here the projection is disk itself, so you need not have to go for the another projection. And now for the surface S3 that I need to find out. For surface S3, again alpha x comma y, so it is oh, I should write down here r comma theta now, not x comma y, r comma theta. Here it is again r comma theta, so it is r cos theta r sine theta, and now here it is z is 1. Yeah, so now here the for the surface S3 it has been shifted to above. So and again if you calculate the surface integral, that will turn out to be pi by 4. So when I calculate the surface integral of S, where S is the total that box, it is surface integral over S1 f dot ds plus surface integral S2 f dot ds plus surface integral S3 f dot ds. So this is pi plus pi by 4 plus pi by 4. So this will be 2 pi by 2, pi by 2 plus pi is 3 pi by 2. So you will have answer, final answer as 3 pi by 2. So of course there are many questions in a practical, so I just suggest you that please solve question from the practical. You will get the complete solution. You will get the complete ideas about this problem. Thank you for attending the lecture.